What's going on, guys? Welcome back. My name is Brandon. We've got a fun episode in store today. We're going to be welding some cast iron, and this is a viewer requested video. It's going to be a lot of fun. Stick around. So here it is, guys. This is what we've got. We've got a broken handle and we need to reattach it. And they asked that I use a product, silicone bronze. This is not a sponsored video. I paid for this with my own money. To get everybody up to speed, let me explain to you the process because I've done them all on this channel. Over the course of the last year, I've bought several of these pans. I've hung weight off the handle, broken the handle off, recorded that result. Then I've taken various processes and various filler metals, made the repair, hung weight off the handle again, and then recorded the result. Now, the reason I've done this, guys, is because everybody knows that brazing cast iron together is the most acceptable and preferred way. But what if you don't have all the required tools necessary to make that repair? How does repairing it with an alternative method, say stick welding it together, compare to, say, MIG welding it together? Well, I've compiled a series, a cast iron welding series that I'll put up here. And if you have a certain machine and a certain filler wire and you want to know if it works, I've tested it, most likely. You can see this last repair was TIG welding. This handle broke off at 279.8 pounds or 126 kilograms. A viewer requested that I use a copper and wound stainless wire, and I've heard it from more than just one. Numerous people had said to try this and that it works really good. It broke off at 161.4 pounds after the repair, so it decreased its strength by 118.4 pounds, which is a 42% reduction in overall strength. So I have done this same format using pretty much all of these processes, using regular MIG wire, using stainless steel wire, using nickel rods, using MIG Weld, and the one we just talked about, copper and stainless, and I'm sure there's a lot that I've forgotten. So if you are wondering how your repair will stack up compared to the next, head over to that playlist, check it out. There's a lot of information in there. It'll tell you how to detect if it's cast iron, how to tell if it's cast steel. There's lots of information. If you need to repair some cast iron, that's the place to go. Now, this isn't a, foolproof scientific test, guys. This is just a rough garage-based test with some rough results. Yes, every time we repair this or grind it and re-weld on it, we are changing the grain structure just a little bit. It's not a huge deal. We're not x-raying any of this stuff, but this will just give you a rough idea of how the process that you may have in the filler metal that you want to try compares to maybe something else. Welding cast iron is not that difficult as long as you follow a few basic steps, and we're going to talk about them today, and we talk about it as well in that series. First thing we got to do is we got to prep this joint, clean everything up, and get it ready to be welded back together. Now, textbooks would have you use a chisel and a hammer to clean out the joint, and that is to prevent any contamination from getting into the weld area. We're just going to use a regular grinder disc, and again, like I said, guys, this is just a rough test. This isn't a fully scientific thing. Basically, I hang weight off the end of this handle after the repair is made, and we just compare it and take that number and find out what it is. Generally, when cast iron breaks and after you've repaired it, it will never break in the weld. Very seldom, if ever, if you've done it right. It'll always break at the toe of the weld, and that is because the grain structure has been changed a little bit as you're welding it. And we're going to talk about all these things as we go. I'm going to be using my Fronius Transsteel 2200 to make this repair, and just simply for the reason that this is the machine I've used to make all the other repairs, so that way it's just one less variable. We're keeping everything consistent. We got to feed it off the top. Let's spin this around. I don't use these little 2-pound spools a lot, guys. The reason for that is I buy the bigger spool, but I don't use silicone bronze, hardly if ever, so I just went with a small spool. That way I'm not wasting it, because this stuff is rather expensive. And if you want to know about this wire, I'll have links to this wire and everything else pretty much you see me using down below into the video description. You can check it out. You can click the links and it'll bring you to where the link takes you, and you can do research or whatever else you want to look at. When you're using silicon bronze, they recommend you use a U-groove roller versus like a V-groove that you would use for, you know, like solid steel wire. U-groove would be the same thing that you'd use for aluminum, just because the silicon bronze wire is softer than hard steel. So the U-groove will help it not deform, and they also recommend that you use like a Teflon liner. But you can get by with V-groove rollers and a standard liner, and that's what we're going to be doing here today. But if you do have problems, just know that a U-groove and a Teflon liner will help with any feeding issues so you don't get bird's nest inside. This welder has a lot of features, guys. One of the features amongst many that I really like, it has a jog feature, and you don't have to take the MIG gun apart to feed wire through it. It'll feed through the end itself. I'll show you. A lot of MIG guns won't do this, or a lot of machines won't do this. You normally have to take off your nozzle and your contact tip to be able to get it to go through. There it is. We also have a little nugget that broke out too that we're going to have to put back on. So like I said, this isn't a perfectly scientific test, but this will give you an idea. You can see I've got things beveled back a little bit. You don't want a really smooth surface. If you can manage it, guys, leave a little bit of tooth on it. Something that it will bind to. You can see how it's like kind of an abrasive area, because we're not melting the base metal when we do this. We're actually laying in this filler material. It's basically like glue. We're gluing it. This actually ends up being MIG brazing, not necessarily MIG welding. And the reason it's brazing is because the temperature of this is going to remain under 2,000 degrees Fahrenheit. Anything over 2,000 Fahrenheit becomes welding. We're not melting the base metal, so again, that lends to the brazing as well. So now I'm just going to switch over my tank, because with silicon bronze we use straight argon. I went on to Blue Demon's website and I wasn't able to get any technical information on the setup for this, so I found some basic information online for 030 silicon bronze wire. Silicon bronze is a copper-based filler metal, and it contains 3% silicone, a small amount of manganese, tin, and zinc, and it's great for using it on thin metals and where corrosion resistance is important. It's saying the recommended parameters for 30 thousandths wire is 130 to 160 amps, which is 21 to 23 volts. That's what we're using. We're using pure argon. Those seem a little high to me, but it is what it is. I'm not going to argue with the experts. They know more about it than me. And these are the recommended welding parameters for MIG. And we are on the right polarity. DC electrode positive. Your stinger or your MIG gun is going to be positive, and your ground or your earth is going to be connected to negative. I had a debate not too long ago about opening valves on compressed air tanks. So for non-flammable gases, you stand off to the side. You don't stand in front. You don't stand behind. Preferably stand off to the side, away from the gauge outlet, but you don't have to. You can stand on this side of it, and you turn the valve on very slowly. You just crack it, and the reason that you crack it slowly is that if this diaphragm inside this gauge were to explode, it's not going to explode into you. And you open non-flammable tanks up all the way, because inside, especially on oxygen tanks, you want the valve opened all the way, because these valves seal when you have them opening up. It's called the back sealing valve. So when you open this valve up all the way, you're sealing the packing inside this valve and preventing it from leaking up around this stem. Now, the reason that you want these open all the way, especially with oxygen, maybe not so important with argon and in C25, is that oxygen is an accelerator. So if you have a leak through your valve stem here, and it's a slight leak, and you have a spark or a flame, you're adding an accelerant to it, because oxygen is an accelerant. Although it's not flammable, it will accelerate the flame by adding fuel to it, because oxygen is the fuel. So when you open up your tanks, crack them slowly, open them up all the way until they seal. You don't have to go nuts. Don't crank them so open that the next person, if there's someone else using it, that they actually think the valve's closed, because you don't want to over open it. You could do damage to it as well. So just a little something to think about when you're opening up valves. Stand off to the side, not behind it, not in front of it. And another great thing I love about this welder, there's lots of them, this is just a really nice welder, is it has a gas purge. Press this energizes the solenoid, and it stays energized for 30 seconds. So if you forget to, like, you walk away, you have an emergency, you're not going to have an empty tank. Let me press this, but show you what it's doing on the gauge. And now I'm free to come over here and adjust it to 25. And there it is. Now, each gauge is different, but this flow meter adjusts to the center of the ball, as you can see right there. It explains how to do it. Some are to the top, some are to the bottom. This one's to the middle. Just know your flow meter so that you can set it properly. And because this is saying 130 to 150 amps, let's just go to 140. So on this machine, you can set it by wire thickness. You can toggle it over to amperage, or you can toggle it over to wire feed speed. So let's go to amperage. We'll set it for 140. And that's giving me 19.6 for voltage. Now we are going to be doing a preheat on this, guys, but this is what I do and how I like to do it. I actually weld the part together by putting a couple tacks on it. Then we can put the preheat on it. And what that does is that prevents us from having to handle a extremely hot part and then try to get everything to line up properly while it's scalding hot. It just makes it super hard. You will not have any issues doing it this way. That key's in there just like that. So we are going to put a little small tack on that, right where it sits, right where it's keyed, to hold that handle on there. There's all kinds of ways to make a repair, guys. This is just the way I choose to do it, and it's worked well for me in the past. Wow, does that flow nice? I'm going to like this, I can tell you right now, right off. Now it's going to form a little ball on the end, guys, when you stop welding. You're going to want to make sure you get rid of that. Now your stick out or your contact to work distance is going to be pretty much just what you would do for any short circuit MIG on steel. You're going to keep about a 3/8 of an inch stick out. Now I'm going to be adding a little preheat, guys, and the reason for that is that when you heat up the cast iron, what you're doing is you're eliminating some of that shock that the cast iron gets going from room temperature to hot welding metal temperature. Rather than this part being at 70 degrees as it sits here and then going to, I'm just going to throw an arbitrary number out there, less than 2,000 degrees, that's a huge swing, 70 to 2,000. If we can get it from, let's say, 500 degrees, heat that part up, now it's going from 500 to 2,000. It's less of a temperature swing. Then we're going to weld this up using little short beads. We're going to peen it with a hammer, and what that does, that helps elongate the metal inside that joint. In other words, you're kind of like mashing the metal out and smushing it into that joint. Those are the non-technical terms, obviously. And what that's going to do is that's going to help the part absorb some of that expansion and contraction properties. I'm not a metallurgist, I'm just kind of explaining it to you, how I understand it and how it appears to work to me. I've had pretty good success with welding cast iron, and I've done it a lot of different ways, and I also have done it a bunch of different ways that I know won't work, that I won't attempt. This also goes without saying, guys, I'm using a cast iron pan because it's a material I think we can all agree that is made of cast iron. When I've used other known substances, people will accuse it of being steel or cast steel, saying that that's not really a valid repair because I'm using cast steel. Well, this is a material that we can admit is cast iron. There's no debating that. It says cast iron on it. We call them a cast iron pan, so we have to believe that it's cast iron. And I discourage you from repairing cast iron pans. There's just too much liability involved, guys. I know a lot of you guys probably have the old cast iron pans, and a lot of you reach out to me asking me to repair them, and I won't. I do not repair cast iron pans for people because there's just too much liability. God forbid this handle broke off and someone was using it, and in my general experience, cast iron will never break within the weld. The part that you put down, it's always going to break outside the weld area at the toe, like I mentioned. And that's just the part of cast iron. It's brittle. It's really, really strong. It's really, really hard. But at the same time, it's also brittle. It doesn't have a lot of flexible characteristics. For reliability reasons, I would encourage you to never repair cast iron. Even if it's your own stuff, I would never repair a cast iron pan, guys. It's just not worth it. God forbid something happened. Even if your pan was some collectible item worth, you know, $500 for this extraordinary pan, and that you want to just hang it on a wall as a showpiece, there's nothing to say that down the road that pan may not be in your possession and someone else could acquire that pan, put that on their stove, and something bad could happen. And we don't need that. It's just not worth it, guys. There's just too much liability involved. So now that we've got this heated up for a while, yeah, it's scalding hot. What we're going to do is we're going to go in, we're just going to make really short beads, probably like 1/4 inch beads. We're going to peen it with a peening hammer, and then we're going to go through and just keep doing that, making little tiny stitch welds and just kneading it into the weld joint. And we're going to do both sides. And if you're wondering if welding metal or cast iron on both sides makes it stronger, I have a video for that too. We tested it. I'll put a link up above. Just go check out that cast iron series. It'll answer a lot of your questions that you might have about repairing cast iron. I use a chipping hammer, guys, to peen it, although not a peening hammer. It applies a little more force and kind of kneads that weld metal down in there a little bit quicker for me as far as I'm concerned. A needle scaler is another good tool that you could use to do this if you had a lot of it. And not that we're going to be doing big long stringers, guys, but you want a push angle with this. You want to be pushing it, not dragging it. Alright, let's get this thing quickly buried in some sand. What this is doing, guys, is this is insulating that weld metal that we just put there, and it's insulating it so it cools down slowly, which is also going to help hopefully prevent any cracking that could form. This just acts as an insulator, slows down the cooling of it drastically. You can also use some other stuff, ash. There's a bunch of other different things you can use as well, but I use sand and I have pretty good luck with it. So it's been 24 hours. Let's see what this is going to look like. See if we got any cracks or whatnot. I don't know. I don't see any. Let's go wire brush it and we'll get a better look at it. So this is where a lot of criticism comes in to my videos from people who really don't have a full understanding of repairing cast iron, and they say, well, you know, it looks terrible, blah, 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 whatever. You know, cast iron is a material that has, you know, some trash in it. So if you do melt the base metal, what's going to happen is you're going to get a lot of trash that floats to the top, and you're going to get porosity. It'd be more controllable if you did this with TIG. I mean, if you needed it to look good. It doesn't have to look good to be strong, I guess is what I'm trying to say. You know, if this was something that needed to have a good looking appearance, you can always grind it off just like any other weld and make it look good. But I love the looks of the silicone. It has this, you know, bronzy copper look, and that's due to the copper that's within it. I'm just going to take this over the bench grinder, grind this little nub off right here, just so that that doesn't skew any results. We'll get this fixtured up and snap this handle off and see what it takes to break it. So here's the setup. I've got this pan clamped down to the table. I've got a shackle hanging off this handle, and I've got this Rubbermaid bucket hanging by these handles. And you guys always comment the real MVP here is this bucket. For this bucket to be able to hold 279.8 pounds or 126 kilograms, by these handles is quite impressive. So now what we do is we are going to fill this bucket up full of weight until this handle snaps off, and then once the handle snaps off, we'll put this bucket on a scale and see how much it is. Then we'll compare that to our original result of 279.8. Okay. Whoa, it did it, yeah! Now we got to see how much weight that is. Alright guys, and here it is. You can see this was a super strong repair. I'm curious to see what the weight ends up being on this, but you can see this is all virgin parent metal that broke out, and you can see right along this edge right here, this is where it broke, again right at the toe of the weld, just like it always does, and then it ended up pulling out all this parent metal. And you can see right here that it actually, the weld actually stayed and it broke elsewhere on this, so the weld was actually stronger than the metal it was being welded to. So without even measuring the weight yet, I can already tell you that this is a successful repair process and a successful repair filler metal, just because, again, the filler metal proved stronger than the actual underlying parent metal. You can see it. That's all fresh cast iron right there that it broke out. Oh my god, this is going to be super heavy. I don't know if I can lift it. Oh my god! Wow, that's crazy. Brand new, unbroken, 279.8 pounds. We repaired it using silicone bronze. It broke off at 252.8 pounds, or 115 kilograms. That's only a 27-pound decrease, 12 kilograms. And even if you went into this video now saying, well, you've already repaired it once and broken it, so over time you've changed the grain structure and you've actually decreased it because you've repaired it one other time. Well, yeah, even as that being the worst case scenario, it's still only a 10% decrease in strength. It's literally 27 pounds of difference from when it was new to when it was repaired actually the second time. That just lends even more credibility to this method and this process and this filler metal to repair it. Super strong. That is incredible, guys. I am totally blown away with those results. So if you guys have a piece of broken cast iron and you're looking to repair it, this is absolutely, without a doubt, a great process and a great filler metal. And as I said in the beginning, the reason I do these kind of like unconventional repairs as compared to like an oxy-acetylene brazing repair, not everybody has access to that equipment. But someone may have a MIG welder, they can go and buy some silicone bronze wire and have an excellent cast iron repair that's strong and durable, and these results I think prove that. So if you guys want to learn more about repairing cast iron, be sure to check out that playlist. I'll have a link up above and down below. There's a ton, as I said, of information in there, probably everything you'll need to know about repairing cast iron. If you're wondering about any of the tools or the equipment that you see me using, I'll have links down below. Some also have promo codes and coupons that will save you a little bit of money at checkout. Until next week, guys, I will see you then. Take care, stay safe, like, comment, subscribe. See ya.